All right, two-column geometry proofs. We're going to go over an example in your textbook, and then we're going to do one on our own here, okay? So find this in your textbook. All right, so two-column geometry proofs. I remember these when I was in grade 10, okay? And I gotta be honest, I will be honest with you, this is one of the things that I didn't like in math. I did not like geometry proofs, and I don't know whether it was just I wasn't ready for it, whether, I don't know, maybe it was a little confusing when it was taught to me. Maybe, I don't know what it was. I did not like them. And I remember the classroom I was in. I remember the blackboard. I remember sitting there like this, like, when can I get out of here? This is brutal. Not knowing that I would be a math teacher for the rest of my life. But anyways, so if this gives you any stress, I'm going to try my very best to make this a little more reasonable. But the nature of these proofs, they're a little bit abstract, right? So where do you start? It's not a formula you follow. It's just a reasoning. So putting your thoughts on paper, showing your reasoning and justification is a little bit tricky. So let's go through this. Two examples, one from the text and one we'll do from scratch. So example 4 from your text, page 29 on this one, Nelson, Foundations of Math 11. Prove that when two straight lines, like AB and CD here, intersect, the vertically opposite angles are equal. This is what we want to prove. Now, vertically opposite angles would be the angles that are colored similarly here, this one, and the one that's straight across the intersection point, okay? Vertically opposite. Even if they're to the side, they're still called vertically opposite. Sometimes some textbooks just call them opposite angles because these ones are horizontally opposite and it's a little confusing. Vertically opposite angles, though, are angles that are straight across the intersection point of two straight lines, okay? So how do we go about doing this? Well, we're going to use the transitive property, which we talked a little bit about the other day, that if two things like A and C, if two things are both equal to the same thing, like B, then A and C are equal to each other, okay? All right, so if you are 16 and person B is 16 and you're the same age as person B and there's someone else that's also the same age as person B, then you are the same age as that other person. You see that? By way of you're equal to the same thing. So how do we start this? Well, you start with something that you know to be true, and you're trying to find some kind of overlapping connection. So we're going to start here by saying that angle AEC, that's this angle right here, and angle AED, that's this one right here, AED, they are equal to 180 degrees. How do we know that? Because
CD is 180.
Yeah, because CD is a straight line, and these two angles are supplementary. So there's your justification, supplementary. Awesome. Now, what can I do? I can rearrange this little statement to say that angle AEC, that's this one in blue, that's now green, okay, is equal to 180 minus angle AED. And that's just by subtracting from both sides. So we call that the subtraction property. So now I have this. I have what AEC equals in terms of another angle. So now what we'll do is we will switch gears a little bit, take a look at the same diagram, but I'm going to say that angle BED, that's this one, BED, and angle AED, notice this is the same angle that we used in the first statement, that those are equal to 180 by the same property. They are supplementary angles. Okay. Now, what you should be noticing here is that I have used this angle AED twice in my reasoning. Okay, so that BED, that's this one, BED, when I rearrange this equation, equals 180 minus AED by the subtraction property again. And what you should notice here is that I have this part of this equation and this part of this equation are identical. So it's kind of like this angle here is equal to this one, and this angle here is also equal to this one. So two things are equal to the same third thing. Therefore, those two things are equal to each other. And so because they equal the same expression, I can say that this angle and this angle are the same. And that is using our newly found transitive property. So that's a simple, basic sort of two-column geometric proof. Let two things equal the same third thing, and then you can prove that they're Equal. Yep.
Do we have to use two-column proof in geometric proving?
You have to know how to do this. Yes, you have to do.
So in
yeah.
every proof,
Not in every proof. No. You have to know how to do this. So if I say show a two-column proof
and you need,
proving that these two angles are the
and
same.
we need to remember all the justification.
Yeah. Yeah. There's only 3 things to remember here so far.
But
The property of
a lot.
Okay, the property of supplementary angles, right? So now you start to build your vocabulary. You start to build your understanding. So you understand what supplementary angles are. You know what the subtraction property is because I've subtracted the same thing from
So
two
that's
sides of an
addition.
equation. And you know what the transitive property is. So those 3 things, you should know what those 3 things mean in this context.
Yeah.
Okay? All right. So don't think about every possible justification or every possible situation. Just think about the one thing that we're focused on and know this well. Then we'll move to another thing and we'll know that one well. And then we'll have more, we'll start to build our knowledge, okay? So don't worry about every possible type of justification. Just focus on one thing at a time. All right, so 2-column proof. This statement is from your textbook. It's a presentation in 2 columns of a statement with a justification leading to some kind of conclusion that you're trying to prove, okay? So think about this like a court of law, right? The defense is trying to get you off for this serious crime that you've been charged with, and so they make certain statements with certain proofs, and they, at the end, hopefully will conclude that you're completely innocent, okay? Here's the statement, here's why you should believe this, here's another statement, why you should believe this, so here's my conclusion.
Yeah.
Okay, so please jot this down into your notes. Let's do this together so we can work from scratch on this one. So it says, prove that corresponding angles are equal. Okay, write this down, guys. Prove that corresponding angles are equal.
What? How do you?
I will explain what corresponding angles are. You might not have heard of that yet,
No.
so
How do you spell that?
corresponding.
Corresponding.
Corresponding. These are 2 R's there.
对称，不是对称。
O-R-R. Corresponding. Now, corresponding angles are angles that when 2 lines are parallel and a line intersects a straight line intersects both those parallel lines. And again, I think we'll talk a little bit more about this as we move through the course and next course. But this is called a transversal because it transverses both lines, it cuts across both lines. Corresponding angles are angles that are formed that have the same orientation, so they open up the same way, and they're formed by a transversal cutting 2 parallel lines. So 1 and 3 are what we would call corresponding angles.
Can we prove this?
Yes, we can. Yeah, we're gonna do
Well,
this.
remember this is not
All right. Okay, so the first statement I'm going to make is a statement about angles 1 and 2. I'm going to introduce this angle right here, 2. And this is should be very familiar to what we just talked about. So
Yeah.
what can I say about angles 1 and 2?
They add up into 180.
Angle 1 plus angle 2 equals 180. And that's because they are supplementary. Okay, thank you. Okay, supplementary property, supplementary angle. You can just say supplementary angles. Okay? Angles 1 and 2 are equal to 180 because they're supplementary. All right. Now, we rearranged this statement before, didn't we? I'm going to let angle 1 equal 180 minus what?
Angle 2.
Yeah, minus angle 2. Okay? And this is because of the subtraction property. And is there only one way to do this? Nope. There's many ways you could do this. But this is the way I'm choosing to do this. All right, so I'm going to now talk about, do you know what? I'm going to talk about angle 3 and angle 2. There's a relationship there. Do you guys know what?
I know that they add up to 180.
Angle 3 plus angle 2
By that.
is equal to 180.
Why?
So this is because with parallel lines, okay, interior angles formed by the transversal like this, they add up to 180.
Why? How to
Because of the property, we don't have to prove that.
Yeah,
Because
so,
of the
so that is not
because of the property of alternate interior angles are supplementary. Okay, so write this down. Sorry, this is actually same side. So same side interior angles and I'll write this just to be a little more clear to parallel lines are supplementary.
So this is not need to be proved.
So think about, this does not need to be proven, no. Think about this. This is a square, right? If these are parallel, if this is 90, okay, what does this have to be? 90. If I were to move this line over a little bit, this line gets bigger, or this angle gets bigger, this angle gets smaller. But they still have to add up to 180. Or sorry, all of the angles have to add up to 360. So that means that these add up to 180, so these have to add up to 180. And no matter how, what kind of an angle you put here, this will still get bigger and bigger, this will get smaller and smaller, so they'll still add up to 180. All right, so that's a new property that you can use. And I'm going to rearrange this one as well. So I'm going to go angle 3 is 180 minus angle 2. And that's going to be subtraction property. Yes, Bola?
Sorry, what angles would you refer to as adjacent angles? Like
Adjacent?
what angles would you refer to?
I'll answer that question later. It's not have to do with this one. It has to do with this question, so I'm not answering that right now because bell just rang, so I'll finish this up. So what can I say as a concluding statement here?
Angle 1 equals angle 3.
Angle 1 equals angle 3, and we see that in the proof because angle 1 equals 180 minus angle 2, and angle 3 is 180 minus angle 2. So what property do we use there for this? Yep, transitive property.
Is it alternate?
No.
No, there is
Okay, there you go. All right, so here's your assignment for section 1.4. Please finish that for next class. Bye.